Hello, welcome to Circuit Moments. What I'd like to do today is introduce another technique for solving circuit problems. This technique is called mesh analysis. Remember from an earlier session, we had a circuit that looked somewhat like this, and we were asked to basically solve. And it could be that we wanted to find the voltage across the 3K resistor, or we wanted to find the current in the 3K resistor, or maybe the voltage across the 1K or the 2K, or the appropriate currents. And we were asked to actually use Kirchhoff's voltage law and also Kirchhoff's current law. All right. So just as a quick little reminder, how did we do this? Well, really the first thing that we actually did was we just defined some currents. We were arbitrary in the way we actually chose those directions. So we could say I've got a current sitting here. I'm going to call that current I1. I've got a current sitting over here. I'm going to call that current I2. And then maybe there's another current here, which we'll call I3. So my choice of directions was an arbitrary choice, didn't matter really. Now where it was important though was the consistency of labeling our voltages. So if the current was going in this direction, I labeled the voltage across that 1K resistor as plus minus. Current going in this direction, voltage across the 3K resistor was plus minus, and then the current going in this direction, the voltage polarity was plus minus, current flowing from a high to a low. All right, so that was our starting point. Then what did we do? Well, we said, look, let's draw some loops here. Where do we have loops? Well, I have a loop here. I could call that loop 1. And then what did I do? I summed the voltages around the loop. Did it matter which way I went round the loop? No. So in this case, I'm just going to go this way. Let's have a little look at loop number 1. All right, so here we go. Loop 1. What did we do? We said if I'm going up in polarity, I'm going to call it positive. If I'm dropping in polarity, I'm going to call it negative. Okay, so here we are, start here. So going around loop 1, what do we have? That's a minus to a plus, so we're going to call that 20. I come across the resistor, the 1K resistor. I'm dropping. That's a plus minus. Voltage across that resistor is what? It's I1 times 1K, so that's a minus I1 times that 1K. Now I come to the 3K resistor, and I've got what? Plus to a minus, so I'm dropping. So the voltage there is a what? A minus. That's going to be an I3 times that 3K resistor. And all of that is, we've completed the loop, so all of that is equal to 0. That was our first loop. That gave us one equation. All right, we got another equation from another loop. We'll call that loop number 2. And once again, we can simply go around the loop in any direction. So if we go the same way or the other way, it really doesn't matter. Look, I'll go the other way, an anti-clockwise direction. I'm starting here. What do I have? I'm going from a plus to a minus, plus to a minus. I'm dropping. So we could say that's what, a minus 10. So this is really what, loop 2. That's a minus 10. Okay, then I come across here. I'm dropping again, aren't I? Plus to a minus. So that is a minus what? I2 times that 2K resistor. And then I come across the 3K. Once again, I'm going in this direction. So I'm going from a plus to a minus. I'm actually dropping again. So that's a minus what? I3 times 3K. And all of that is equal to 0. All right, now remember, we're trying to solve, and we're going to try to solve for I1, I2, and I3. All right, we've got 2 equations at the moment with 3 unknowns. So how do I get my third equation? Well, really the only thing I can do here is to use Kirchhoff's current law and sum the currents. Now remember, our little convention was if the current's going in, we'll call it positive. If it's going out, we'll call it negative. All right, so the sum of currents entering that node is equal to 0. I1's going in. So there we go, I1's going in. Okay, what else is going in? I2's going in, so we'll say it's a plus I2. I3 is going out, so we're going to say it's a minus I3, and all of that is equal to 0. All right, we now have, what, 3 equations, 3 unknowns, and we now should be able to manipulate these equations and solve for I1, I2, and I3. And once we have those currents, we can find the voltages across the resistors if we so choose to do that. So we're going to use those equations to solve. Look, that's what we've done in some of the earlier sessions. What I want to introduce you now to is what is called mesh analysis, okay? And really that's if you like, a slightly formal technique of really doing the same thing. It's perhaps in some cases a little easier because you actually eliminate one of the variables as you really draw your, or write down, I should say, your mesh currents. Can we use mesh analysis for any circuit? Well, look, for most of the circuits you're going to be dealing with, we certainly can. The issue here is that the circuit must be planar. In other words, we really can't have a situation where we've got one loop that's actually running on top of the other loop. So you've got to look to see if you can make it planar without that kind of crossing over situation. All right, what we're going to do is we're going to define, in this case, just 2 mesh currents. We're going to define a mesh current here, I1, and a mesh current over here, which is I2. Now, I'm going to always draw my mesh currents in the same direction, in a clockwise direction, like you see here. Do you have to do this? Well, no, you don't have to. But I think if you do this, it's going to avoid a lot of confusion, okay? What we're effectively going to do, though, as we travel around in that clockwise direction, is really sum the voltages around that mesh current direction. Okay, so once again, if we get a voltage source over here and we're going from a minus to a plus as we're going in that direction, we're going to simply call it positive. As we hit a resistor here, because we're following the direction of that current, that I1 mesh, so it's going to be a plus to a minus. And so it's a minus, basically, I1 times 1K. So let's write down our first mesh current equation. So it's the I1 mesh. All right, here we go. So we're going to start here. We've got what? 20. Okay. Hit the resistor. That's a minus what? I1 times 1K. And then we hit this 3K resistor. Well, let's look at the current in that 3K resistor from a mesh point of view. We've got I1 going this way. We've got the I2 going this way. So we could say that this is what? An I1 minus an I2. And if we're looking at the I1 mesh current equation, we're having the I1 lead, the I1 coming first, which means we're going to put a minus sign there. We're going to multiply that by 3K, and then that is all equal to 0. There is our first mesh equation, okay? Now what we can do with this is we can sort of collect terms together. We might as well do this really right now. So what can I do? I can take these 2 bits to the other side, and so I'm left with what? A 20 is equal to I1 times 1K plus, I've got my I1 minus I2 times 3K. All right. Let's expand the bracket here. So we've got 20 is equal to I1 1K, and then I've got what? A plus I1 3K, and then I've got what, a minus here, haven't I? I2 3K. So our final step here is what? Just to collect the I1s together here. So we've got 20 is equal to I1 times 4K, and I've got a minus I2 times 3K. And I could say, well, look, there's one equation that I have really that's in terms of this I1 and I2 as defined by my mesh currents over here. All right, let's look at the I2 mesh equation. All right, so where can we start? Well, we can start right here, traveling in this direction. So right now we're going to hit that 3K resistor. So what have we got going through the 3K resistor? From the I2 mesh point of view, we've got I2 minus I1. I'm going to put that in a bracket. that's multiplied by the 3k, and because we're dropping in potential from an I2 point of view, we're going to say that's what? A minus sitting in front. Then we've got what? We've got a minus I2 times 2k, and then we've got a plus 10, and all of that is really equal to 0. Okay, so what can we do here? Well, we could take this part and take it over to the other side, couldn't we? So what does that leave us with? That leaves us with 10, and that's going to be equal to, this would be I2 minus I1 times 3k. This bit goes over to the other side, and so that is really what? A plus I2 times 2k. Okay, let's expand the bracket out here. So we have 10 is equal to, well, we've got I2 times 3k, and we've got a minus I1 times 3k, and then a plus I2 times 2k. So let's just collect all our terms together. We've got 10 is going to be equal to how many I1s? We've got a minus I1 times 3k, and then how many I2s? We've got 3 of them there and 2 of them there. So what have we got? We've got a plus I2 times 5k. And that's our second mesh current equation with our terms collected together. Okay, we've got our 2 mesh equations. Take a break at this point and see if you can now solve for the I1 and I2. And I'll see you next time.